What's up, friends? I'm back on here again doing another coding challenge. I'm KG.codes, and I've been doing pretty good. Last couple of weeks, I've been doing a coding challenge like every weekend, so I'm at least doing one problem a week. Back on here doing another one, doing another medium level problem. So I know like the last probably 2 months or so, I've been doing like easy problems. So now I'm gonna do a medium problem. Another medium problem. I did one last week too. This one's called generate parentheses. This one should be like a little bit of a challenge. I did review it earlier, so I'm not just starting from scratch, but it's still one of those ones that you got to think through regardless. So I'm gonna practice in front of y'all and answer any questions, and after I get done I might answer some questions if anybody's on here asking questions. So I'm live on TikTok, Instagram, Facebook, Twitch, YouTube, and Twitter all at the same time. So if you want to switch to another platform, you can to watch this however you want to do. I think I'm gonna go ahead and get started. This problem is called generate parentheses on KG.codes. This is where you can go do the coding challenges at. These are questions that typically get asked in big tech software engineering interviews. So a lot of times they'll have different rounds of the interview, and at least one or two of the rounds will be a coding challenge. And this is like big tech companies, some medium, some small ones. Some companies don't ask these, but enough companies ask these that it's become sort of a thing in the industry. And so they had this website called KG.codes that allows you to practice the questions. So I'm gonna do one of the questions called generate parentheses. It's a medium. I don't know what companies is asked at because I don't have a premium version, but I'm sure it's asked at a number of companies. And it goes as such: given in pairs of parentheses, write a function to generate all combinations of well-formed parentheses. And the example that they give you is when n equals 3. So it's saying in pairs of parentheses. So that means that a pair is like a open parentheses and a closed parentheses. That is what denotes a pair. That's what a pair is. And so it's saying if you have 3, how many different combinations of 3 parentheses can you get, and return that to me in a list. And so with 3 pairs of parentheses, you can have a pair on the outer edges and like a pair on kind of in the middle, and then a pair like directly in the middle. Or you can have 1 pair on the outer edge and then 2 pairs in the middle. Or you can have a pair, 2 pairs on both sides, but then a pair inside of the first pair. Or you can have a pair inside of the second pair. Or you can just have 3 pairs in a row. So I think y'all understand what it's asking based on how I'm explaining. It's saying if you have 3 pairs, what are the different combinations of open and closed parentheses can you possibly have? And you need to return that, all the different combinations in a list, in an array. And then if like I have just 1, then of course all it can be is just this 1 pair. If it's saying give me the combinations for 1 pair of parentheses. And so this was 3, and then of course it could be the constraints down here say it can be in the number of pairs can be, it's always greater than or equal to 1, or less than or equal to 8. So it's 1 through 8. It can't be no more than 8. So the constraints are something in an interview that the interviewer may give to you, or you may have to ask them. Like you may not get the constraints. You may have to ask them like, what are the ranges, the constraints of n? What is the lowest it can be? What's the highest it can be? Because that may come into play in your algorithm and the things that you choose to do in the algorithm. So if you ever seen me do these before, you know that I like to think through the problem first, try to figure out, how I would do it in my head and kind of what the approach is for solving it in your mind. Like you have to kind of figure out how to solve it in your head first before you figure out how to solve it in code. Like you got to know how to solve the problem, period. You got to understand it enough. This is the point where you would ask the interviewer clarifying questions like what the constraints are. Like I said before, you'd ask some questions about the problem. You would read through the problem yourself again just to make sure you understand it. This is a chance for the interviewer to sort of give you help if they're nice like that. Some of them ain't really, it just depends on your interview. But most of them, they're trying to help you. And if you ask clarifying questions, they maybe can, instead of just jumping in the code, they may be able to protect you from like sort of going down a bad path that they've seen other people go down before. But if you don't talk and you don't communicate what you're thinking, then they can't help you, if that makes sense. So I'm gonna read it again. It's generate parentheses and giving in pairs of parentheses, write a function to generate all combinations of well-formed parentheses. So the first thing that sticks out to me is it's saying combinations. Like that's one of those keywords when you start studying data structures and algorithms. You start to see patterns. You start to see trends in the problems that lend themselves to certain solutions that you already know. And when I see combinations, that's when I know that I'm gonna have to be like, I'm gonna be taking steps, and then at every step, I'm gonna have to look at all the possible combinations of the next step. So how I'm thinking about this here is when you open when you start creating parentheses, like valid parentheses. So it has to be, they said well-formed parentheses, or you could say valid parentheses. A valid parentheses always has a closing side. So it can't be like open 4 of these and only close 2. Like it's gotta always be a closing parentheses for every single one. So if you have 3 opens, you gotta have 3 closed. So in every single one of these, the number of open parentheses are equal to the number of closed parentheses. And not only that, it's gotta be, you gotta have enough parentheses on this side to be able to close them on that side, if that makes sense. So every time you open a parentheses up, you gotta be able to properly close it before the end of the string. And I also know that if I have 3, that I know that 3 pairs, it says given in pairs, I know that each of these strings is going to be, if it's a pair and I'm getting 3 pairs, then a pair is 2. So 3 times 2 is 6. So I know, and then here, if it's 1 pair, then I know 1 times 2 is 2. So 3 times 2 is 6. That means that each of these strings is always going to be 6. And I know there's always going to be 3 opens and 3 closed, no matter what I do. I just need to make sure that they're creating a valid parentheses. So how would I do that? Like if I'm doing this in my head, like let's say I need to write all these combinations down. How I'm going to start is I always know I got to start with an open parenthesis. I can't put a closed parentheses before I have an open one. Like I said, it got to be a valid, it's got to be a valid parentheses. And so I know my first one, I'm always going to open one up. And so I'm always going to put in each of these open parentheses. So I already know how that's going to go. So when I start this first one, I put an open one. Then this second place, I got options. The 2 options that you have are to either do an open parentheses or another closed parentheses. That's where your combinations come in. And so I know in the second one, I can either do an open parentheses. So here I did an open parentheses. Here you do an open parentheses. Here you do a closed parentheses. And so if I choose to do another open parentheses, then it starts to divert into combinations, if that makes sense. So like how I'm getting 1, 2, 3, 4, 5 different combinations here is because when I get to this second slide, I ask myself, can I put an open parentheses or a closed parentheses? And so in this one, I put a closed parentheses. And this one, and this one, I put an open parentheses. So like, it's hard to explain, but like, basically this is where your combinations divert, and you have to write code that's able to basically try all these different combinations within your algorithm. So like you start with this one, it always starts with this one. These are the same, basically kind of the same. You're always going to start with this open, but the next step you can choose to close or open. Then the next step you can choose to close or open. Where the further difficulty comes in is you never, like I said earlier, you can never close a parentheses unless you already have enough open parentheses. You have to have more open parentheses than you have closed parentheses, so you have something to close in the parentheses, if that makes sense. You can never close a parentheses if you don't have a one that's open that you can close, if that makes sense. So every time I make a decision of whether I want to put an open parentheses or close a parenthesis, I want to try both paths and set off a new chain, I need to check to make sure I have enough open parentheses. On the other side of that, when I can't open more parentheses than 3, because like I said, I can only, these are pairs. So once I get to 3 open parentheses, then that's too many. I don't need to try the combinations. So like when I get here, let's just try this one right here. So let's say I decide I start here and I say I can do open parentheses or close parentheses. Well, I know I can't do a close parentheses because it's the start and I don't have enough opens to close it. So I'm going to start with an open. Then here I can decide whether I'm going to do open or close. Let's say for the sake of argument, I decide to do open. So that's this combination. And then here is go to the third one. I decide to do open again. And then here when I get to the fourth spot, the fourth iteration, then I say, okay, well, I got too many. I already got enough opens. I got 3 opens, so I can't put any more opens. So my only choice is to do a close. So then I do close here. Again, I still got too many opens, so I do a close, and then I do a close again. And then once I get to 3 times 2, 6, which is my max number of pairs I can have for n, then I stop and I have this combination. On this one, let's say the first 2 times I chose open, and then the third time I decided to choose close. And so I have to check close that I have enough opens to close. And then this time I decided to do open. And this time I decided to do close. And every time I have to check to make sure I have enough opens before I close. And make sure when I get to the third, make sure I count how many opens I have so I don't max out 3. And then once I get to 6, then I know I'm done. So it's basically just like the hard part to explain with this is that every time I get to a new state here, I can either do an open, a close, or both. And so if I do both, that actually creates, what can I compare it to? Like an alternate dimension, like a combination or a different dimension of train that I'm going to go down through. And that's how I would do this problem if I was doing it by hand. I would just, create all these different strings by just trying all these different combinations in each character. But at each step, I would always make sure that I still have a well-formed valid parentheses when I get to 6. And so that's how I would do it by hand. But in code, it's a little harder to do. And the thing that I see in this problem is combination. So I know that I'm going to have to do some sort of recursion or some sort of backtracking algorithm in order to try all these different combinations, because I'm basically going to say, okay, when I get to the next spot, I need to try this one, and then when I go to the next slot for both of those two, I need to try 2 more, and it becomes this like branching tree of combinations. And then once I get to 6 on all these combinations, I just add them into my array as like a valid answer, and then I return the whole set of answers that I found when I went through this. And so there'll be times when I get to spots where I'm like, oh, I have to stop right here because I have too many open ones, or I have to stop, or I can't do a closed one here because I don't have enough open ones. And so that's basically how I solve it. I know if y'all are watching, let me read some comments and see if anybody understanding what I'm saying, because it's tough. Somebody asking on TikTok, would they give these questions in the interview? Yes, they will give harder questions than this in the interview. This is a medium. So if you're going for a higher role, like a senior, or even probably like senior, they probably ask a medium. They may ask a medium to a junior, but senior and above, they'll definitely ask medium problems. But yeah, it's a recursion problem. Somebody said, Yeezy said on TikTok, it's a recursion problem for sure. Backtracking problem, you're gonna have to use recursion. Yeah, it's definitely a difficult one. Yeezy says this is a junior one. I mean, yeah, I mean, I guess I could kind of see that one. LeetCode says it's a medium. I think it's a little harder than the junior problem. I think you can get tripped up on this one. If you, like, I think I think you definitely can get tripped up on this one. Now, I feel like the junior problem is valid parentheses. There's where they just give you a set of parentheses. You have to decide if it's valid, and usually you use probably like a stack or something to do that. To make sure that you have enough on this side. So an interviewer might ask you valid parentheses first, just to see if you can make sure you know what a valid parentheses is. And then they might give you this problem as a level up as a second part of the interview to do this problem, which is a little bit harder than valid parentheses. If you've ever did that one on LeetCode too. So yeah, so anyway, that's how I would explain it. I'll probably explain it a lot faster in a real interview, but I'm just trying to, explain my thought process on here to y'all. Somebody said principal role, expect 1 medium, 1 hard in 30-40 minutes. Exactly. You'd have to do these really fast. You couldn't talk as much as I'm talking, for sure, in a real interview. But I think for a junior or a medium level dev, they'll probably give you an easy and a medium in about 45 minutes, most likely. They'll give you like I just said, they'll probably give you the problem called valid parentheses and then generate parentheses right after, maybe to build upon it. But it just depends on the interview. Sometimes they'll give you totally different thing. Is it possible to see a sample of the code? Yeah, I'm about to actually, Digenesis, what's up, man? I'm gonna actually do it. I'm gonna do the code live. Hopefully I don't screw it up. I'm gonna try my best. So somebody said they went for a dev role and they got 1 medium. Yep, I've interviewed for a lot of different roles, and it just depends on the interview. Sometimes they give you 1 medium, sometimes they give you 1 hard, sometimes they give you a couple easies. It just depends. It really does. But yeah, they love to ask these in interviews. So let me check the YouTube. ChatGPT could do this. Yeah, ChatGPT could do everything. I mean, I get it, but they still asking these in interviews, so we still got to learn them for now. Or at least I do. Still have to learn them for now. Maybe that'll change. I see a lot of companies changing are not asking these questions. But for now, I just talked with one of my friends. He just went through an interview process, and they still were asking these. So, and he was going for a big company that we all know. So yeah. Anyway, if you want the big bucks, these are the kind of stuff they're gonna ask. But it seems really difficult for some of y'all, and probably for some of y'all that's done it before, it may be easy. But for me, these problems are really hard. Even after I was a software developer for a long time, these problems are a different skill set that you have to build. At first, it looks intimidating, like it's almost impossible to kind of learn how to do these trivia type problems. But like I said earlier, once you start to learn the problems, the patterns, and you start to do them in the algorithms, you'll start to be able to recognize patterns and problems, and also assign those patterns to data structures and algorithms that you already know, and you'll start to be able to kind of do pattern recognition. And that's why I always preach, learn the fundamentals. It's boring, but if you just go in here and do 1,000 problems, I've seen people fail interviews that way, versus somebody that learns the fundamentals, and then they go and do 100 problems or 200 problems that they see on the company's top list, and they pass the interview. So it's quantity over or quality over quantity. So anyway, that's enough talking. So I've explained it to my approach. Now I'm going to jump over to the code over here. And then I'm also going to show this on the screen so y'all can see the problem at the top. Because I'm getting a little fancy with these coding interviews. Now I can show stuff on the screen and stuff. So, trying to do my thing on here. Let me move this down a little bit. So I'm going to use JavaScript. I know somebody going to hate on that, but that's my language of choice for these things. I'm also going to change this from var to const. If you know JavaScript, you know why I would change that. And Yeah, I don't know why LeetCode puts var there instead of const. That's not me that did that. Because every time I do these, somebody jump in and say that. It's like, why did you use that? So anyway, probably if I was in an interview when I got here, I would probably tell the interviewer what I plan to do. And what I plan to do here is, like somebody said in the comments on TikTok, is use recursion. Whenever I see a problem with combination in it, the word combination, or find the different ways, I already know that it's gonna be a backtracking algorithm, what they call a backtracking algorithm, and a recursive algorithm. I know that there's gonna be some point in my algorithm where I'm gonna call the same function again with a different option in it. So remember, like I was saying, when we first were trying to solve the problem in my head, every time I get to a new step, I have to try either an open parentheses or a closed parentheses. And I know that that point in my code, I'm going to have to call a function to try out the open one and go down the path of trying the closed one. And I'm going to have to keep track of these different paths and store them into some sort of object that gets all my results. And so let's start with that. Like, let's start the algorithm with the results. So I'm going to say all combinations. And it's an array. Because here, the output, this output, it's an array. So I'm going to go ahead and just create that so I don't miss it at the end. And then I know I have to return that out of this function. All combinations. This thing don't give me no help of like typing help. And somebody, Walker Smith, don't conflate recursion with backtracking. Yeah, I mean, I'll probably say this is a backtracking algorithm, but I am going to be calling the same function over again for sure. So I'm going to be calling the same function inside of the same function. So generate parentheses. I got n is what my actual input. So that's this for anybody that doesn't know, or I'm sorry, I got it at the top. So that's this up here. I can't see what y'all see at the top of the screen. But yeah, so I got all combinations. I'm going to return that. So what I actually want to do here is go ahead and I'm just going to create a function called generate. And it's going to take in some parameters. And appreciate the vote of confidence, Walker. Appreciate that. I'm going to try to do my best, man. So yeah, I'm going to create this. And what I want to do is actually call this here generate. And this is kind of going to be like the function that I end up calling like over and over again to generate my new. It's almost like generate combination or whatever. I don't know. I'm just going to call it generate though. And I know I need to pass n into it. So I need n. So I'm going to put that there. And what I want to do here is, oh yeah, I need to pass all combinations into it. I'm basically going to pass everything into it that I have so far. So I'm going to pass all combinations into it. And I'm going to actually put that down here in the function name. And the next thing I want to pass into it, I need to keep track of, let me see, what are the things I said I need to keep track of when I'm doing this problem? So I need to keep track of the result. So I got that passed in. And that's the thing, when you're doing backtracking, your function that you're like backtracking with or recursively calling, you need to keep track of like a state at every point that it's called. And so the one thing I said is I need to know how many of these opens that I've called and how many of these close that I've called, because I need to be able to check that I don't have too many opens and that I don't try to close when I don't have enough opens. So I almost need to know the amount of these, because I need to have less of these closed than I have opens to know I can add another close, if that makes sense. So I need to keep track of the number of each of these that I have. I also need to keep track of this whole string that I'm building, these different combinations that I'm building at each step, because it's gonna divert once I start. I'm gonna like be calling more and more, creating more branches to my tree, which is like a depth first search, sort of, but it's like a upside down tree, kind of like a maybe not a binary tree. Well, yeah, maybe this is a binary tree, since it's only, I'm opening it. It's only one or two options, either opening or closing a parenthesis. So anyway, like I said earlier, I need to keep track of number of opens, it's gonna get kind of ugly. Oops, I need to move this over a little bit. Number of closes, and I need to keep track of current, I'm gonna call it current combination. This is like wrapping a line here, so please don't be disturbed by that. I know it looks bad. Or maybe I can like drop this down here. It still looks bad. But y'all just know that this is the same line. It just dropped down a line right here. My names are just kind of long or whatever, but I'm making these long names because I just want to be clear. I want y'all to be know what these variables are, because otherwise it gets really confusing. So here I'm going to start with 0 in each of those places, and then an empty string. So this one is n. We know what that one is. That comes from the problem. The n is the number of combinations that we can have. So I could actually write number of combinations here, like total number, or no, my bad, not number of combinations, number of pairs. So I could say number of pairs. So that number of pairs is here. I'm passing it in here, and I'm just renaming it in this function. Number of open parentheses, number of closed parentheses, current combination string, and then all combinations, which is a array. And if I had more room, I'd probably name these like I would probably name this an array. Like I like to name in JavaScript, especially because it's dynamically typed. I like to actually name the variables more close to what type of data structure they are. But here my name's already getting kind of crazy, so I'm just gonna keep it like that. So yeah, I think this is good. I got everything passed in. I'm gonna start with 0 number of opens, n number of pairs, 0 number of opens, 0 number of closes. The string, the combination, the current combination is empty when I start. All combinations is getting passed as empty. I need to pass this in by reference because I need to mutate it and then return it here. So I think I'm good. So now I'm gonna get down in here and figure out what I want to do. So here, this is gonna be like a lot of this I have memorized, and this is where it comes into knowing how to do combinatory problems. I don't know how to say it, but like problems where you got to find the combinations and different ways of things. You sort of memorize the algorithm for doing it or forms of the algorithm for doing it because you do so many problems, and that's where the pattern recognition comes in. So a lot of it I do just have in my head to do. Whereas if I was doing this from just trying to do this from just my skill or whatever, purely, I probably would do this stuff like out of order. I would probably, I don't know, just do different things. And I kind of am doing it out of order because I'm trying to explain it. But I'm kind of probably doing it in a weird order. But anyway, the first thing that I would do is, this seems like the end, but I actually would check when I need to terminate this generate. And that's basically, I would create an if statement, and I would say, it's like I said over here, like whenever I get to 6, whenever I get to double my pairs, which is because each pair has an open and close, so it's actually 2 times 3 here, 2 times 1 here. Whenever I get to 6, each of these are 6. Whenever I get to 6, I know I need to stop and return that as an answer and add it to my output. So that might be the last thing you do, but if you kind of know like how these algorithms work, usually it might be the first thing that you decide to do. In my mind, it's the first thing to do. So I would say if I mean, I could do this probably in a number of ways, but I'm probably going to look at the current combination string. And if that length is equal to, I'm going to say, I guess it would be n times 2 because it's a pair, but then minus 1 because, wait, no, wouldn't it be minus 1? No, I think it's just n times 2. Yeah, I'm sorry. N times 2. I'm thinking about indexing. But yeah, it's just the size of this, n times 2. Because it's always n times 2, like I said over here. So yeah, once it's n times 2, I know I'm done. And what I actually would do I would push into all combinations. I'm going to push into that array the current combination, because that means I got a good combination that's done. And that's kind of giving me, and I actually would return right here, I'd be done. That would terminate this generate from doing anything else once it returns here. And so that would add to all combinations a new combination that I have before I return it. But down here is kind of where the true work begins, is where I actually want to find my combinations, like, and build up these combination strings. And how I want to do that is by making recursive calls to generate or backtracking. And so what backtracking is you are helping you to find the combinations of the different different paths to pursue to build some sort of result set. And when you get to a path that isn't valid anymore, then you want to stop there and either backtrack, or where you kind of backtrack, and once you get to that path and you terminate it, you kind of backtrack that way, and then you still pursue your other paths. But your code is kind of just doing it automatically, if that makes sense, based on how you write it. So what I actually want to check is, and I'm actually just going to write this how I wrote it the first time I did this, these type of problems. So I know I need to call generate again here, but what do I need to pass into it? So I need to pass in n again, because number of pairs will always be number of pairs. So actually we'll pass in number of pairs again, number of opens again. Actually, I'm just gonna pass all of these as is right now, and then we're gonna change them. So remember what I said earlier about I need to try every time when I get here, I need to either try open parentheses or a close parentheses. I got two options. So I'm actually going to call recursive functions with both those options. And how I do that is with current combination. That's my string that I'm building up the options. Remember, when we passed it in, it's empty. So I'm going to add, for the first one, I'm going to add open. And for the second one, I'm going to try the close. This is where I'm actually trying different paths. I'm going down this generation path with an open. I'm going down this generation path with a close. And so that allows me to sort of try these different paths. It's a little more complicated than this, but we're going to get to that. And so number of pairs is always going to be the same. Number of opens, if I'm adding an open here, number of opens actually is increasing here. So I'm going to add a 1 here. Here I'm adding a close, so number of closes is actually increasing here. So when I call this, it's all about trying to update the state every time I recursively call this. And so you see the different state is updating depending on whether I'm trying the open path, or I'm trying the close path. So here I'm actually increasing the number of closes, so I'm adding a +1 to that. And when it comes back into the function, it's going to have a different state in that path that I'm going down. And so, but the problem with that is, remember what I said earlier, and yeah, all combinations will always be the same. I'm just passing this state through. And remember, this is it's passed by reference. So it's always just going to keep the state of all my results that I've found so far throughout all the recursive calls. So, and it's the only one I'm doing like that. So everything else is kind of like a state. It's like a in-memory state that's being lost whenever I terminate a path. but all combinations is actually gonna be returned later, if that makes sense. So, but anyway, like I can't just call both of these, right? Like I can't always try open and I can't always try close. Remember what I said earlier is like I can't start with a close one because I don't have enough. I need to have enough open ones to even try a close. I need to have more opens than I have closed before I can try a close. So let's write that logic in my algorithm here. So I can say if number of opens is less than number of closes, then I can add a close. Only then is the only time I can add it, because I gotta have more. And that doesn't solve everything. The other thing as I said is that I can't have more opens than 3, because you can only have equal opens and closed, or you can only have 3 opens and 3 closes, because they're pairs. They have to be valid parentheses or whatever. So I actually can put another if statement here and say is number of opens less than or equal to number, or does it have to be less than or equal to? I think it got to be less than, because if I'm adding one, yeah, so it got to be less than number of pairs, because I'm still adding one inside of this if statement. So as long as it's less than, I'm gonna indent that. As long as it's less than, then I'm at the last one. Once it's equal, then I can't add anymore. Yeah, because once I get to 3, I can't add another one. So it's got to be less than number of pairs. And then if this is always less than number of pairs, and I always stop there, and I always make sure I have at least less number. Number of opens less than number. Yeah, as long as I have number of opens greater than number of closes. I'm sorry. Number of opens has to be greater than number of closes. So that I make sure that I have something to close. Like it's always got to be something to close. It's got to be an open to close. So it's always got to be greater than, and then I can add the close here by adding 1 here and by adding the close here to current combination. And yeah, I think that is pretty much it. These variables are really they're really long, but I probably wouldn't name these this long if I was doing a real interview, because the interviewer would understand. But this is just for the sake of this live, so y'all understand what all these variables are doing. But anyway, yeah, so I think this is good. So if I got to this point in the interview, and I notice because it's wrapping, the line is wrapping, it looks kind of weird. I don't know. Let me see what it look like if I make it. Nah, I don't really look no more better. It's just tiny. But anyway, if I got to this point in the interview, so some interviews I've been in, and y'all probably maybe have, some of y'all had the same experience. Some interviews you be in or you're in, they might let you run the code in some sort of execution state, or some sort of depending on the language, like it'll compile and run the code, or if like it's a interpreted language, it'll be some interpreter you can run it in. Some interviews don't have anything to run it in. Some interviews, the interviewer expects you to mentally run the code manually and make sure it works for them. And you need to prove to me that the code works yourself by hand, and don't even run it, because they want to know how you think, and they want to know how you debug code. Some interviewers, when you get the code written, they'll have some sort of like run button, and you can just run it, and it'll run it against a bunch of test cases, and then you'll be able to know that it's correct. But I'm gonna do it both ways. I'm gonna run through the code manual. I'm gonna run through and make sure my code works like I think it does, and then I'm gonna actually run the code with LeetCode.com and kind of give the best of both worlds with that. So what I do that is, and this usually takes so long, that's why I hate to do it, but I'm trying to think. I think I'm gonna do n equals 2 on this one. So actually I'm gonna run it manually first so I can get the answer for n equals 2. And then I'm gonna run it automatically with the runner first, and then I'm gonna do it manually. I usually don't do this on live, but I'm gonna do it this time because I don't feel like coming up with a new. I don't feel like doing this long one by hand. It's gonna take forever to do, and backtracking is actually like really hard to do by hand. So yeah, so I'm just gonna actually. LeetCode allows you to run these. It's like a run button up here. So I'm gonna run this against a couple test cases, and I might have some kind of issues. Okay, yeah, I got some issue here, and that's why I shouldn't have ran it first. I should have actually looked through it first, which is what I usually do. So yeah, number of pairs is not in. I renamed it, so I have to rename it there. And that was stupid. That's why you're supposed to review your code first, but I'm trying to do something different this time. So yeah, I got both these test cases passed. I'm actually gonna add another test case here, test case 3, where n equals 2. And I'm gonna run it again and get that test case answer. So yeah, my code works with n equals 2, and it's this. And this is what I'm actually gonna use to run this. So like this is why I did it, because I don't wanna. This is gonna take forever to do. Y'all don't wanna watch me do this. But this one, if you've been on here before, you've seen me do some of these. It takes so long to manually go through. That's why in interviews, when they manually make you go through the code, it's usually a problem that you can go through pretty quick, because it takes a really long time to do. So anyway, I'm gonna do n equals 2. So y'all at least see that my code works. Usually I would do it manually before I ran it, but I'm just changing the order this time, because I mean it just depends on the interview anyway, so it's not like it's wrong. Some interviews do let you run it pretty quickly. So let's try it when n equals 2. So this is n, this is our input, n equals 2. And all combinations. And then I'm actually gonna put current combinations. Oh shoot, this is gonna suck, man. I don't know if I'm gonna finish this. We'll see how it goes. If I get in the middle of this and it's just dragging, I'm probably just gonna not do this one. Every time I get on here, I do this manual thing, so it ain't like I don't do it, but if I get tired, I'm just gonna be like, nah, I'm not doing this. I don't think I've ever been in an interview where they actually make you do a backtracking problem by hand, or like you do it by hand but never explain it by hand. So I don't know. I'm gonna try, man. I'm gonna try my best, y'all. So what I usually do to do these by hand is I take note of every variable and keep track of it at the top. And I'm actually gonna put this down. It's gonna be easier to put it down here, because this is where all the work gonna be happening. Not much happening up here. And do I got everything? Yeah, these are all my variables. Numbers of opens. Yeah, number of pairs. Yeah. So I'm gonna go line by line here. Start here. Set. This is getting set equal to an empty array. N is equal to 2. So we got that. Oh, and number. I'm missing one. Number of closes. And this one, I'm changing it to number of pairs anyway, so I'm just gonna set this equal to 2 and just get rid of this. And then, so yeah, then we get this is equal to 0. Number of closes is equal to 0. I'm just looking at line number 7, right? And I'm just putting the values of everything at that line of execution. And then we go inside this generate function. We get here to this first line inside of here, and it says, is combination length, which is 0 right now, equal to number of pairs times 2, which is 4. No, it's not, so we're gonna skip this whole thing. Is number opens less than number of pairs? Yes, because number opens is less than 2. is less than number of pairs too. So I'm gonna go inside of here and actually gonna generate. Yeah, man, it's gonna be some crazy backtracking, but yeah, I'm gonna actually generate right here. So number of pairs is staying the same. Number of opens getting 1 added to it. Number of closes is getting 1. No, it's not getting anything added to it. Current combinations getting this added to it. Open. And then all combinations staying the same. So I actually go inside of here again. It's getting called recursively. Inside here again. With this new state here. And so it's current combination length, which is this now, equal to number of pairs times 2. No, because it's just 1. It's not equal to number of pairs times 2, which is 4. So I skip this again. Is number of opens less than number of pairs? It's still 1, still less than number of pairs. So I'm actually going to try this again. And I'm going to increase the number of opens. I'm going to add another open here again. Then I'm going to go into this again. And basically it's going to go through the same thing. Is it equal to 4 yet? No. I'm going to go in here. Is number of opens less than number of pairs? So at this point, it actually isn't less than number of pairs. So I'm actually going to skip this state. It's because it's equal to number of pairs. Number of opens is equal. So I already got enough opens. Then number of opens, is number of opens greater than number of closes? Yes, it is. Number of opens is greater than number of closes. So I'm actually going to increase my number of closes now to 1. And I'm actually going to add the closing to the current combination here. We'll get that. And then I'm going to go down this state. And then come in here again in that state. Is it equal to 4? No, because I only got 3 things in here. It's not equal to number of pairs times 2. Is number of opens? Number of opens is still less than number of pairs. Or is it less than number of pairs? No, so this state's still going to get skipped because this hasn't changed, right? Number of opens greater than number of closes? Yes, it is, because 2 is greater than 1. So I'm going to go in again, add increment number of closes to give it to 2, and add a close here to get rear. So I actually got a good combination here. I'm going to come back in here again because I'm calling it here. Is current combination length? Now it's 4. Is it equal to number of pairs times 2? Number of pairs times 2 is 2 times 2 is 4. So this is equal. I'm going to add to all combinations my current combination. So I'm actually going to add this in here as a combination. So I got one combination. Now you would think that I'm done, but the problem was that I started a whole nother. I have to backtrack all the way back to where I actually could have ran the code here too. Like the first time I went through this code and I ran this generate and came back in here recursively, this state was also true, and I could have ran this recursively, and that would have started a whole nother thread of recursive generate calls to give me a whole nother combination. Now, am I going to do that? I guess I can. I guess I can do it. So if I go back to number of pairs will be the same. Number of opens will be it'll be 1. Yeah, it'll be 1 because I would have had to start with 1 open. Number of closes would have been still 0, and I would be here with that, and I would be at this state right here. And then let's say, so that this would be after this part. I would have gotten all this in here, and I would have had this here, and I would have had this. This is hard, really hard to think about, but I would have gotten to this point and had to run this code. And it would have said number of opens greater than number of closes. Yes, it is. Number of opens is greater than number of closes. So I actually would then add 1 here and add a closing here. And then I would have came back up here inside of here again, and I would have started a whole nother group of combinations, and it would have split again. But I think here, if I was in an interview, this is actually probably where I would stop explaining. I wouldn't go through the whole thing. But no, maybe I can go through the whole thing. Let me, because I think it's only 2 combinations. So let me see if I can try. If I got to this state here, this wouldn't be true. Is number of opens less than number of pairs? Yes. So I would go through this again here and add, make this 2, and then add this one, and its number of opens less than number of closes, and no. So I think I would just backtrack here, and then when I came through here again, yeah, its number of opens greater than number of closes. Yeah, it actually is greater than number of closes. So then, yeah, but see, these would be 2 different current combinations. So it actually wouldn't be. Yeah, because this wouldn't be. Yeah, this wouldn't be changed. So yeah, it would just get a little bit crazy trying, because then I would have to keep state of both of these going in here, and so I'm probably not gonna do all this stuff. This is leak code for people that's asking. But yeah, it would be a whole, yeah, that's why it would be like, I'd have to keep state of like multiple iterations of this. But I think at this point, I would realize that my code is working properly, and I would just stop here in the interview because it would take too long. So yeah, I'm just gonna stop there. I at least got this first combination, and I do think I would have got the second combination too. So yeah, that's what you would halfway do. But I'm not about to go through all those combinations for sure, because it's just going crazy with the threads. But yeah, so that's how you would do that. And then the next thing that you would talk about, well, yeah, you would run it, see if it works. If you could run it, they may not let you run it. They may or may not, just depends. So I would try to run it. I ran it here, it works. The next thing they would ask about is space and time complexity. So, or time and space complexity in big O notation. So big O notation or space and time complexity measure how your algorithm scales based on the size of the input. Does it scale? Does the performance of your algorithm as far as space and time that it uses, does it, based on the size of your input, which in our case is n, which is the number here, based on the size of it, like how big this number is, based on that size of that input, is the algorithm scaling disproportionately to the size of the input? Is it scaling linearly to the size of the input? Is it actually doing less operations? Like, as that gets bigger, does the number of operations get linearly larger, or does it like exponentially just grow out of control the bigger it gets? Does it get worse the bigger it gets, like disproportionately worse? And if that's the case, then you probably got a bad algorithm. If it just linearly gets worse, like the number, like for every more input that you have, you get more the same relative amount of operations or space used, then it's probably, fine, but that's kind of how big O notation works, or time complexity and space complexity work. And what big O notation is just a way to specify what the space and time complexity are. It's a way to notate what it is. So yeah, somebody want me to put it in dark mode. Shoot, I think I tried to do that before. I don't know how to do it. I don't even know where you go to do that at. I'm gonna see how it looks, man. Oh yeah, I guess that look alright. Okay. Yeah, I'll put it in dark mode. Y'all hate light mode, man. But anyway, yeah, I guess it is kind of burning my eyes, but where was I? Yeah, so yeah, space complexity, time complexity. And so when I look at this, oh shoot, I don't even know what the space and time complexity of this is. Let me think about it. So have n pairs of parentheses, and for each of those pairs, I need to call a recursive function. And there's basically, oh yeah, this is a tough one because now so at most I'm gonna call this twice. Again, every time I call it once, I may have 2 more calls to make recursively, which doesn't, I mean, it just seems linear. And all combinations, and I don't think that's growing exponentially either. So I want to say it's big O of n as far as time complexity, and space complexity, I want to say big O of n as well, but I don't even know how to calculate the number of combinations it is possible. Because with 2, it was 3. No, with 2, it was 2 combinations. Let me see. Oh, shoot. Why is this not coming up? Yeah, with 2, it was 2 combinations. With 3, it was 5 combinations. So that's how much. So time complexity is the number of operations that you're doing in relation to the size of the input. Space complexity, the amount of data, how much, like based on the data structure you're using, are these data structures growing based on the size of your input? And somebody said, what Bhavesh said, 2 to the nth power. You might be right, and that might be why I'm having a hard time trying to figure it out, because then it's because of the 2 combinations or the 2 paths that you have as far as an opening and closing bracket. Yeah, I really don't know. Honestly, I don't know. But 2 to the nth power kind of makes sense. But yeah, I don't know. So all I can do is explain to y'all what so what happens when number of open and close are 0. Do you mean like in the input? So like the constraint says that it can't be 0. It has to be at least 1 pair. So that means if it's 1 pair, that means it's at least 1 open and close, because the whole thing, a pair is in pairs. So if n equals 1, then it's actually 2 things, and it's, or whatever n is, that means you got 1 of one and you got 1 of the other. And then here you have 3 of the open and you have 3 of the close, whatever n is. So it's always like double the size of n. So you never have 0. I start with 0 here because I haven't even started yet. Like, this is just the first call to just get the chain going. Are code like these used in real jobs or interviews? I'm not in this field. That's a tough question. So I do think these particular types of problems that they ask in interviews aren't necessarily tied to everyday work that you do, but the concepts behind it, time complexity, space complexity, writing algorithms, knowing how to use data structures, knowing the syntax, those concepts are things you do need to use in the job. But you wouldn't be doing a problem like this in a job. This is a made up problem, a trivia problem, for better lack of a term, that are used in interviews to help provide a structure to the interview for them to see if you have these skills, that we're talking about. So in this case, I got the skills to write the problem, but I don't have the skills to talk about the time and space complexity. I'm trying to think of what it would be in this case. And yeah, it's kind of tough. So, cause yeah, I know that you're gonna terminate each path once you get to 6. But But yeah, 6 is based on n. Yeah, that's tough. Yeah, I work at ZDev. These types of interview problems definitely help to show who can manage complex algorithms. Yeah, for sure. Never understood the concept of this. Are y'all supposed to just memorize the word? You mean the concept of coding? Yeah, I memorized the syntax for JavaScript. That's why I use JavaScript for these problems. Python is easier. Yeah, I could see that Python's easier, but I use JavaScript a lot. All right, man. Somebody said, go ahead and just submit. All right, I'm gonna go ahead and submit it, man. Cause I don't even know. I don't even know what the I don't even know what the time complexity. This is the first time I got on here and I don't know what the time complexity is. All right, so LeetCode, I forgot to explain it, but LeetCode, I ran it earlier, but LeetCode also lets you submit up here with the submit button, and what that does is submit it against all the other LeetCode submissions ever, or I guess, and it gives it some more test cases. Had 8. There were only 8 test cases possible because of our constraints. You can only have 1 through 8 pairs. Yeah, so it says I beat 41% in runtime complexity, or runtime. It's not really complexity, but just runtime. And I did better than 63% with memory. But take these with a grain of salt. I think it like give you something different every time. But the best thing, the good thing is it got it accepted. And I think this is like the first time that this is the first time I actually ran this one. So yeah, I did good on that one. To only have like one issue with it. Shoot, I'm not trying to do what am I doing, man? I'm trying to get to where I was. What the heck? How do I get back to that screen that was on? I was trying, because I wanted to see the, oh, it's like over here or something. The heck? I don't know what's going on. What in the world? It's like what? Why is this? You gotta do better, man. So why is this over here now? Anyway, man, what I wanted to do was analyze the complexity because I don't know what it is. So, okay. So yeah, you're right. Bavesh on YouTube. N 2 to the n power. I definitely didn't get that actually. So, and this is big old N. Okay, so why is that the case though? Oh my God, this is screwed up, man. What the heck is wrong with this? Why is it doing this? Where is the? All right, yeah, give me the default layout again, cause y'all, it just went crazy. Oh, I guess this only shows up over here. And it's, oh, you have to drag it over here. Okay, anyway, man, yeah, so I actually gonna ask ChatGPT to explain to me the time complexity, because I don't understand it. I don't understand why it's 2 to the n power. So I'm gonna ask ChatGPT. I'm gonna put it back on the screen once I get all this. Make sure y'all can't just see all my history and stuff. This how you learn, man. All right. explain the time and space complexity. No problem. All right. This is a classic backtracking problem from leak code. Generate parentheses. And the time complexity is bounded by the number of valid combinations in pairs of parentheses, which is given by the Catalan number. What the heck is all of this, man? What? Oh, my mouse just went dead. Shoot. I charged my mouse for 2 seconds. I don't get it, man. It's confusing. I got my other mouse somewhere. Hold on, y'all. I'm gonna get my other mouse. Guess I don't have another mouse. Alright. Let's charge this one for a second. Should be back now. Yeah, so maybe one of y'all can explain this. This like some strong math, man. I don't know what the heck. I mean, leak code said it's 2 to the n power. I don't know what the heck all this is. This thing right here, it's saying it's 4 to the nth power. I'm not even trying to understand this, man. I might try to learn this later. I don't know. So what? No, man. What? What is this? I've never seen space and time complexity be this complicated. You know what? Go back here and go to editorial. No, I don't have the money for that. Dang, man. Somebody in here gonna explain the time complexity. I mean, this is I get it. It's like all these combinations. So I know how to do the problem, but yeah, that time complexity, damn. No wonder I couldn't figure it out in my head. So he's saying time complexity is n times 2n, where n equals 2n. 2 to the nth power. What? Okay, we have n. Okay, yeah. Where n equals 2 times n. Yeah, so okay, so let me just stop being just giving up in my mind. So I knew that when we first started a problem, that's what I said, like whatever n was, multiplied times 2, because that's how many places we got to fill. So if n is 3, then little n is 3, then it's times 2 is 6. That's how long each combination has to be. So that's what they're saying right here. And he's saying, yeah, so we have n times 2 places to fill, and for every place we have a maximum of 2 choices. So that makes sense. We have 6. So like if little n equals 3, then we have 6 places, and for every place we got 2 choices, either open or close parentheses. But how does it get 2 to the n? That's what I don't get. I don't get how you get 2 to the n. Maybe I'm just not good at math. And why he have... Oh, we have multiplied our TC by a factor of n, because every time we hit the base case, we copy our current OP, which is the size of n, into the answer vector. Every time we hit our base case. This must be some junk he's doing in C, in what is this? C++. Yeah, C++. That I'm not doing. I'm sorry, y'all. I'm about to be done with this in a minute. I'm just trying to understand. Anybody explain this in JavaScript? He don't explain the time complexity. I don't need the answer. I know how to do the problem. Yeah, man. ChatGPT let me down, man. Why? 2 to the... So where's the damn... Man, I don't understand this at all, man. Yeah, this is the only thing I could think is you just have to know. These combinations are really tough to do in time complexity. I have no idea how to do this. Yeah, I don't know. Maybe somebody else know. Let me see. Let me see what the comments are. Nested loops are usually n squared instead of 2 to the n. So those are easy. Like I could do the problems where it's like linear time complexity or n squared time complexity, or yeah, even like backwards, like, you know what I'm saying? But it's just, yeah, this dang freaking what you call it? It's hard, man. Is combination problems, time complexity. It's like you gotta do all these. It's like you doing a dang algebra or something. So anyway, I'm done with the problem for now. That's how you do the problem. I couldn't figure that out. That's gonna be something I'm gonna have to work on off time for next time. Cause that stumped me. I'm not even gonna lie. So Akshay said, basically for each option in the list, you have the choice to either use it or not, which is 2 options. Yeah. I guess, man. I mean, I think I could land at the 2 to the nth power. But what it was saying on ChatGPT, it was talking about like 4 to the nth power plus 4 and all that. I don't know what the heck it was going to. But yeah, brush up on it, bro. Yeah, definitely will. I do not know. I don't know if he's talking to me or somebody else, but yeah, I definitely don't know what that is. And make sure I'm not missing any comment. I'm gonna answer some comments for a little while. Yeah, everybody's talking about the light mode. I turned it to dark mode. Can you suggest minimum time to complete JavaScript for ServiceNow developer roles? Sorry for disturbing. No problem. Hope plays. To complete JavaScript, or you mean learn JavaScript? I would say, and you want to learn you want to learn how to write logic for ServiceNow. I wouldn't put a time limit on it. I I would start learning the basics like immediately. I mean, I think with AI now, AI can kind of supercharge your learning. I would say you could get pretty decent at JavaScript in probably like 6 months. It just depends on your time, because everybody's 6 months ain't the same. Like if you could work a full-time job, your 6 months ain't gonna be the same as somebody that's like not working at all. So the time limit thing, I try not to put a time on things, but if you really grind it out, like you get started now, within 6 months to a year, you can be pretty proficient. But just make sure you're learning the right things, that you're just staying focused, that you're actually trying to build things within ServiceNow, like start an account or whatever, even if you got to pay for it, and start like building dashboards in there and building logic in there and all that stuff. And building, forms and stuff in ServiceNow. I'm guessing that's what you're trying to do. Or you're saying a ServiceNow developer role, so just working at the company, but not actually. I'm thinking about like a ServiceNow administrator. You're talking about just being a developer for the company ServiceNow, a JavaScript developer. Yeah, I mean, still the same. Like, I think it'll probably take you like 6 months to just learn JavaScript, and then probably another 6 months to like study LeetCode, because ServiceNow, they're a big enough company where they're going to be asking you a combination probably of, I don't know for sure, but I'm thinking it's probably a combination of these type of problems in JavaScript, and they'll probably make you build some like web components, web application stuff, like give you like the problem I used to get was like build a clock in JavaScript and HTML and CSS, but you're using some sort of framework or something. But you're building it, most of the logic is in JavaScript. So like, just learn how to build web components. So yeah, I think you start on that, take some time, but you could do it quicker than a year. I've seen people do it quicker, but I think this market is so crazy. You got to be so competitive that, I just tell everybody a year at this point, because even people that's working now, they're getting laid off and stuff. It's taking them a year to find a new job, and they already got experience. They already know the languages and stuff. So, anyway. Good thing is data structure and algorithms transfer between languages, right? So, whatever you do, just the advice I would give, when you pick a language, just stick with it and get proficient. Learn the fundamentals of programming, data structures, algorithms, and then it'll be much easier to pick up your next language when you need to. So when you're going for jobs that call for it, or you're going to do a project that calls for it, you'll be able to switch languages pretty quick. A lot of people get hung up on, I got to learn Python, then I got to learn JavaScript, then I need to learn Java, then I need to learn C#, then I need to learn, all these other languages, and you're spreading yourself too thin. You're not getting any depth in any one of them to like actually build your programming and software development skills. So that's a good point. The comment that somebody had on here. That's Java. Yeah, this is JavaScript that I was coding in for this problem. Getting complacency is difficult. It was taken to the account that the fact that some of the combinations are different sizes. Oh, okay. So it's like, yeah, because you're stopping on, well, no, all the combinations are the same size. I mean, I guess some of the paths that you're going down are stopping. Yeah, it's just tough to even think about. Like, yeah, because you're gonna, yeah, that's a tough one, man. Like, that time complexity on that one is tough. Somebody said the chat GPT thing was wrong. Trust me. I think it was wrong too. I don't know if it was like over analyzing my code or what, man. But I've been doing these for a long time. I don't usually ask chat GPT. I usually just use LeetCode. This is one of the few times I asked chat GPT, and it's like giving me a freaking formula, man. Like, I've never seen anything like this. So I don't know if it's like just trying to overanalyze or what. Or maybe I just don't know. Maybe I'm just tripping. I don't know. But I'm not about to dig into it like that. I have not been I've interviewed for Microsoft, Amazon, Airbnb. I've interviewed for a lot of companies. I ain't never seen nothing like that. So there's some points where I just tap out and I'm like, if somebody give me that in an interview, then hey man, they just got me, because I'm not about to sit there and I'm not about to do a freaking math problem in an interview. And the interviewer don't even understand it. So anyway, I'm 19 and math heavy. I want to start coding. Where do I start? It's mainly for fun though. Oh, so you just want to start coding for fun? Yeah, I would definitely start. I would start with either JavaScript or Python. Because if you want to code for fun, I'm thinking you're probably going to want to do maybe some AI stuff, machine learning stuff maybe. So Python's a good area for that. And you're probably going to want to build like web apps and, stuff on the web that you can see and visualize. So JavaScript's good for that. I would pick one of those. Don't worry about which one. I mean, just do some general research about which one would be better for your interest, so you'll stay motivated, and just pick one of those. And I would start with one of those and then just move on. You'll be able to move on really quickly from there. And I suggest doing start with some, baby projects, kind of like tutorial projects, and then move on to some real projects. You learn the most doing real projects. As far as learning tools, to figure out how you learn. If you learn by visual, YouTube's always good. There's a lot of great teachers and resources on YouTube. There's just so many resources out there. I think Udemy and all the, you can just Google all these places that teach you how to code. It's just, I'm not even gonna go. It's hard for me to even go through it because there's so many good tools. I end up missing a lot when I try to tell people. It's just find the one that's best for you that you stick to. And then of course there's AI. AI is the best teacher because you can literally tell it how to teach you. You can tell it exactly what you want it to do. Now it's doing a bad job of teaching me this time complexity, but I mean the most part, I've learned a lot using it. So anyway. Oh yeah, roadmap.sh is great. Somebody just suggested that. It's overwhelming, but I actually think it's the least overwhelming out of everything, because the internet is the biggest overwhelmer. You get on here and you see people doing this stuff and you just don't really know where to start. But I feel like roadmaps.sh, that's what this is, that somebody just suggested. When you're learning, it kind of just breaks it down a little bit for you. So somebody came on here saying they want to just do something for fun. Let's say they wanted to start working on the front end. They click on that. It looks overwhelming, but it's really kind of giving you a structure though. It's overwhelming because it's a lot, but you're not having analysis paralysis. You literally click on each of these in order from top down, and you learn the basics. I mean, you got to start with how the internet works to start with. Then you start HTML, learning basics of building an HTML page in the old web. Then you learn CSS, how to style your pages and make them look nice. Then you learn JavaScript, how to make your pages dynamic and do things and change dynamically without you having to refresh them and stuff like that. Then you learn how to, source control, and then you learn packages and how to use code that other people have written on your web apps and stuff like that. So it goes in a proper order. Then you start learning frameworks like React, Vue that actually can get you a job. So this thing, it seems overwhelmed, but it's actually putting you in a really good order. And I mean, this is for everything. I mean, if you want to get into AI stuff and anything, back end, yeah, it's a lot, man. So, and they even got these JavaScript. If you just want to start with JavaScript, yeah, it's actually pretty good. Even for if you're going to interview, just as a refresher, to make sure you got a strong command of the language. This is really good. So for coding challenges, I actually recommend AlgoMonster. AlgoMonster.com. It's really good to me because what they do is they focus on the patterns, like I said earlier, top lead code patterns, and they focus on ROI. So They analyze how many questions from each pattern are being asked and what's the best return on investment. Like how easy it is to learn, what's the return on investment, what's the topic. And so like I said earlier, a lot of the questions you see are going to fit into one of these topics or patterns. And most of the patterns are in this green section up here. Like most of the interviews you're going to do are in this green section. And the problem I just did, and my mouse just died again, but I can talk without it for a little while. But most of the patterns you see there is, the one that I just did is actually backtracking, which is like the 5th one down. And it's considered hard to learn. So it's the reason why it's like, kind of confusing as far as like all these different paths and combinations and trying to manually track through it and then figure out the time complexity. I mean, it's tough. It's not the hardest problems here, but it's like the highest difficulty to learn of the best return on investments. Like so these backtracking problems are actually asked a lot in interviews, and they're kind of like, if you're gonna learn anything, you at least need to get to that point before you start doing interviews. And I think dynamic programming is probably when you like, that's when you're kind of maxing out. If you can get to dynamic programming and learn all of that, you can kind of skip divide and conquer, tree, union find, greedy algorithm. Like they don't get asked a lot, and they're like kind of harder to learn sometimes. So yeah. Anyway, I think my mouse should be coming back. Is this leak code types of problems? Yeah. So Algo Monster is leak code style problems. It's just, I'm showing you just their strategy for how they teach you. And yeah, leak code patterns. And you basically learn these algorithms. And once you kind of memorize these algorithms, you learn how to form them to fit different types of problems that you see. And so this is when I started this problem today. It's hard to learn, but I already had learned it from Algo Monster, and I knew it was a backtracking problem because Algo Monster teaches you, when you see the word like combination and ways to do this, you already know it's a backtracking problem. In my mind, I already have an algorithm kind of memorized for backtracking problem. Now, I didn't go and memorize a bunch of solutions off LeetCode.com. I memorized the pattern. So it's much easier. There's 3,000 problems on LeetCode.com. It's much easier to just, sorry, I keep moving that. It's much easier to learn these, 12 patterns versus learning 300 problems. Now, yeah, when you start doing these problems, you're going to start memorizing some of them just inherently. But like if you really focus on these 10 patterns, not even 10, I mean, if you just focus on these top 8, you're going to be in a pretty good spot for the interviews. If you practice a lot of problems in each of these 8 sections and learn just how the different variations of them, you're going to be in a good spot. And yeah, and then they had like a there was some I'm trying to find, they had like this nice chart. Is it roadmap? I don't even know where it is. They had a chart like a couple years ago. And it might have to log in. Let me log in real quick. See if I can log, because I think I paid for lifetime access, I'm pretty sure. But there was like a runtime. Oh yeah, this runtime complexity cheat sheet. Maybe I can learn what the heck. So this is n squared. So that's nested loops. Now 2 to the n squared, that's what I think my problem was. But see, I like this because it's like giving you an example. It's telling you what it is. And see, look what it says right here. Remember, I just said like this is a backtracking problem. Every time I see the word combination, I already know to associate it to backtracking. because of Algo Monster. Really is what taught me, but I mean you can learn it from anywhere. But Algo Monster does a really good job. Grows very rapidly. Avoid. So worst case, if I get in an interview and I know I did a combination problem, I forgot this because I haven't been interviewing in a while, but I would just, if I was going to interview and I didn't necessarily understand why, I would just guess. I would just say, yeah, I think this is big old 2 to the n power because it's a combination problem. I probably would just say that in an interview, even if I didn't understand why. But yeah, because it literally says it right here. So typically what these problems are going to be. Often involves recursion. Yeah, because somebody was saying that earlier. They was like, don't confuse you. Yeah, I guess I get what you're saying. Like you don't want to, they're not the exactly, backtracking and recursion are not the same thing, but backtracking often includes recursion. And it's harder to analyze time complexity at first sight. I mean, yeah, shoot, that's why I was struggling. So here's what it is with that one. But I know I'm gonna know from now on, for sure. Often requires memorization to avoid repeated computations. Yeah, my problem didn't have that, but yeah. So anyway, I kind of got distracted, but oh yeah, so keyword to algorithm. So like it helps you when you see like how many ways, decode ways. That's depth first search, dynamic programming, and I might have got mixed up with the how many ways, but I know I think the one should be in here. Why is the combination one not in here? Well, I thought it used to be in here at least. Substring, sliding window. Yeah, usually use a sliding window. But this, I'm just saying this site is really good for finding the, like, matching, doing the pattern recognition. And there's other ways to learn it. I'm a read and learner. Like I like to be able to read and go back, and I don't like to have to skip video and move the video back and forth. I don't like to have to do that. I just like to be able to go back and look. And I like to be able to copy and paste it to somewhere else where I can review it quickly. That's just how I learn, like, is reading. But I'm surprised they don't have like the combination word in here anywhere. Yeah, that's weird. Because the combination definitely lends itself to a data structure. And depth first search is it's like really similar to can I change this? It's not. I don't know what this is. Decode ways. Oh, you gotta complete this. Oh, this is a problem. I don't want to do a problem right now. I'm trying to find something. And I'm gonna stop showing y'all this once I find it. All right, man. What is this? Stop. I'm giving y'all all my information. What is this? I ain't trying to do this. Yeah, but then this chart they give you shows you like how much you've done on each section, which is pretty cool. Oh, flowchart. Yeah, this is what I was looking for, flowchart. So Algo Monster had this flowchart to help you when you're in an interview, like find what the pattern is you need to go to. So like it'll say, is it a graph? You go, no. If it is a graph, then is it a tree? Then you go to depth first search. Is it related to acyclic graphs, topological sort? Is the problem related to shortest path? Like it just tells you where to, oh, stop doing that. It tells you where to, what to do. And DFS is very associated with backtracking, like depth first search. Because that's kind of what I was doing. It was like a upside down tree. I was breaking off all these paths. And when I got to something that I didn't need to look at, I would just backtrack up and go down the other path. Yeah. And so, yeah, it basically just tells you every time you, like, does it have linked lists? You might need to do this. I mean, this thing is just really good to like use to kind of open up your mind to thinking about trying to get to pattern recognition. Like sliding window. Yep, calculating the min max or something. Asking for number of ways. Yes, is brute force fast enough? Brute force backtracking. Dynamic programming. Yep, so that's kind of where in the area where I was at a little bit. Yep, so yeah, it's pretty cool. So anyway, we can go back here. Yeah, LeetCode is all about patterns. It's the best advice anyone ever gave me. The tree ain't all that. Yeah, once you start to kind of learn those patterns, it gets a lot easier, man. Like I thought I'd never learn this stuff until I broke it down into like those 8 patterns, and it just simplified because I started to notice that all these problems ain't just random. Like they lend themselves to some sort of pattern, and so it just makes it way easier. Because the worst case in the interview, as long as you know the pattern, you can at least get somewhere, instead of just getting to the interview and there's just a problem. You just like, I didn't memorize this problem, so I'm not gonna be able to solve it. That used to be my biggest fear, because they could ask you anything and you can't prepare for it, and then you're just stuck. And so luckily, learning those patterns kind of gives you a tool set to use. Yeah, I love Algo Monster, and there's this thing called Algo Expert out there that's video based. It's good too, but Algo Monster, to me, man, just the way I learn, you got to know the way you learn. It's just a lot better for me. Yeah, bro, drop all that and do NeetCode. Yeah, I mean, and NeetCode is the same. It's the same concept. It's a similar concept, but I mean, I wouldn't say the same, but it's similar in the fact that he's like the guy that made it, are grouping them into patterns, and he's making you do a bunch of problems in each of those patterns, and so you're inherently learning the patterns by doing problems in those groups. But I think if you want to just dig a little bit deeper and just really understand the patterns a little bit more, Algo Expert kind of in combination with NeetCode will help you. I do think using either NeetCode or Algo Monster is better than just going on LeetCode blind and just doing a bunch of problems, because that you're just not gonna get the best return on investment. So I appreciate that comment, Julian, about that. I've been wanting to learn Python algorithmic trading. Any websites for learning that are good? Oh shoot, it was just a website that I was thinking about Python for that I want to suggest, but I can't remember. I need to, you know what? I'm gonna next time I get on here. Yeah, I'm live right now. Next time I get on here, I'm gonna have some resources for folks. Cause me personally, like I've just been using like AI a lot now. Because like when I have a question, I really want a very direct answer very quick. And AI just can give you such a direct answer, and you can keep prompting it, keep asking it. And so I haven't been using a lot of just tools outside of like Algo Monster and stuff, and watching YouTube videos. But there's like Udemy, and there was another site that somebody suggested that was really good. I just can't remember the name of it. I think there's a site called Egghead that's pretty good. I think it's Egghead. Yeah. I don't know why. What was I looking at? I guess I was looking at something on Egghead before. But this is like videos. So it's like short videos. But yeah, they got like JavaScript and I don't know if they have Python on here. Might not have Python, but yeah. And there's like, what are the Udemy competitors? Programming. There was one that I wanted to suggest. Pluralsight was pretty good when I was using it, but I think it's kind of dated now. Dang, it's one that I want to bring up, but I just can't remember what it is. Let me just see. Platforms. Learning to code. Oh yeah, I forgot to mention this one. This is the one I was thinking about too. Code Academy. Code Academy, I heard good things. I think any language. This one, Free Code Camp, I think as far as the best free one, I think Free Code Camp is probably the best free one. It's really good. I mean, it's real. Like, I just get a lot of suggestions for that one, or like plugs for it, I guess. I don't know if it has Python though. Archive coursework. Let me see. Yeah, I guess they have it. I don't know. I think you have to sign up and go through it, but I heard a lot of good things about Free Code. I used it for a little while in the past. So anyway, there's so many resources. Like, it's just really figuring out the way you want to learn. At this point, with AI and with all the resources that have been built out there, if you get stuck on one, just change. Just change one. So, somebody said I didn't go to school for coding. I went to school. I got a computer science degree, but that was like 15 years ago at this point. So I'm learning new stuff now. Like, the stuff they taught me that back then, it was foundational and it was really good. Taught me how to code. But in this industry, what you'll realize, I don't know how long you've been in the industry, but what you'll realize is that you got to keep learning. Like, you can't stop. Like, I didn't learn data structures and algorithms. I did learn data structures and algorithms originally in school. So let me not lie. But as far as leak code problems, I didn't learn that. So I knew the algorithms, I knew certain data structures, but I didn't know how to apply them to these trivia style questions that they ask in these interviews. It's a different ball game. You have to kind of study it. So, that's where I'm at with that. Let me see. I think I'm gonna answer a couple more questions, and I'll probably get off of here. Leak code is so annoying for interviews. Yeah, it sucks. Is this for SWE? Yeah, this is what I was doing earlier. Is this problem here? Oh, I forgot I left this thing sitting up here. This thing. I didn't mean to do that. But it's annoying. But a lot of companies do still ask it. Got to keep your skills sharp. You can't rely on everything. Can't rely on AI for everything. Yeah, for sure. Like we've been using AI. Like, I've been using it on my personal projects. Been using it at work, and it's very good. It's supercharged my workflow. I work way faster than I used to. But there's still a lot of times it digs itself in holes. And if you're not a programmer, if you don't know anything, it's hard for you to dig to help the AI get out of a hole that it's dug itself into. Like, when it starts going down a bad path and it doesn't know it, it just keeps building upon it. And if you don't stop it, it can get to the point where it builds something where I've seen people have to like completely just wipe stuff out and start over again. And so you're using AI, so then people say, well, you're using AI, so you didn't invest that much anyway, so you can just start over. But it's like, when you're working with production code, like, it becomes a different ball game. Like, yeah, it's easy to build a project from scratch, but like something that's been existing for 20, 30 years and it's going in there screwing stuff up, it's not as easy as you say to just like roll stuff back, like, it's implications. So anyway, like, AI is great, but it also I just still see it has limitations, of course. So what's the hardest algorithm for you? That's a good question. What's the hardest algorithm? The hardest one to understand. I mean, those backtracking ones are pretty tough. I'll probably say some of the dynamic programming ones can get kind of tough. Because with dynamic programming, it's like you have to start using memoization and start like storing results. But like, stop repeating the same results and store the data inside of like a dictionary. And usually what the dynamic programming piece gets thrown on top of a problem that's already difficult and just makes it a little bit harder. And so I'd probably say those are the ones because they just take so long to do. So I'll probably say those are probably some of the hardest algorithms to write for me, because it's easy to get out of track. I mean, get out of whack. And then some of the tree problems. I mean, trees are easier than I thought they would be, but they also can be a little difficult too. Linked list problems can kind of be confusing because you're trying to keep references to pointers. So I'll probably say some of those are some of the most harder ones to me. The real job is mostly tickets and features, not much leak code. Yeah, like a real job is not gonna be a bunch of leak code problems every day. This is for interviews, but I have seen cases where programmers write bad algorithms that cause performance issues in production. So they write an algorithm that's, let's say it's n squared time complexity, and inside the algorithm is doing some sort of expensive operations. If you write a better algorithm, you could save the company money. You could save the server resources. They don't have to, deploy as much or give as much resources to whatever your code is running on, because it runs more optimally. Like, I have seen where bad algorithms cost a company money and somebody has to go in and fix it. So knowing big old time complexity, space complexity is important, because you could take down a system if your algorithm isn't built for scale and it's storing too much data in runtime memory, and the machines run out of RAM. If you're on the cloud, it's going to start spinning up more, VMs, or spinning up more resources. It's going to cost your company more money. If you're not on the cloud and you have a limited set of servers and resources, then you're actually just going to max those servers out and they're just going to crash. And so you're just going to have an issue on your hands. So either way, writing good code, good performant code, and knowing the performance of your code, knowing the time complexity of your code matters. I remember when I first started, probably like the first 5-10 years, I didn't really think about time and space complexity that deeply. But once I got into a senior role, then issues started to come up. I started being assigned to those types of issues. And I wouldn't say, probably wasn't that long, but probably 2 or 3 years at least, until I kind of started moving to more complicated stuff. And I started noticing that stuff. And so I was like, yeah, that stuff is important to know. But I don't like how they test it in interviews. I think there's a better way to test it than leak code problems. But I do believe that this stuff is important to know. How long do you think it would take to make a functional AI trading algorithm from scratch? Oh man, I months. Especially now with AI helping you, months. If you know how to code a little bit, and even if you don't know how to code, spend some months learning how to code. Use AI to help you build it. You could build something from scratch in months. Almost anything could be built now in months. Yeah, trees can be easy to trip up on if you're going too fast. Yeah, man, you get lost in it, and then you're in an interview. You're already nervous. That's the part that gets thrown on top. That's why I actually do these lives, because it helps me I'm talking in front of y'all, people watching. It kind of gives me not the same feeling, but a similar feeling of being in an interview, where it's if I can do it in front of, a bunch of people, it's a lot easier, to kind of do it in front of just one interviewer. So, anyway, vibe coding mentality is so scary. It's going to be huge security problems. Yeah. So don't think that I'm just plugging vibe coding it's just the end all be all. I just think you can build stuff really fast now. And if you know how to code, you also can code, you can understand your security issues. You can understand, you can stop the AI from building technical debt, and you can keep, the code clean, and you can, prevent issues. So knowing how to code is still valuable. I believe that at least in the near future, coders will still be around. It may be less of us, but we'll be the ones using the AI. It's just a new abstraction that we're using to build code. Technically my role at my job is software engineer. It's not programmer. It's not coder. So I'm building software solutions. Maybe I'm using AI. Maybe I'm writing the code myself. But my title is actually not program. It never was. Even 10 years ago, it wasn't programmer. So it's more to software development than just writing code anyway. And so I think that AI is just the latest abstraction to kind of help us write, create software in a different way. So, but as far as I've seen, you still need a good bit of technical know-how to keep the AI from. You got to be able to know what to tell the AI what to do and not to do. And the prompting, the context window is still so important. So a lot of these vibe coded apps, you see people, like when you start an app from scratch with AI, it looks really nice. But when you think about an app that has built up to 100,000 lines of code, it's not as easy for the AI to deal with that. Once it's this compounding error, it's compounding technical debt that gets built up over time by humans, especially with AI. And once the context is so large that the AI can't see it all at the same time without being very expensive, then those problems start to compound until the AI can't really dig itself out. That's what I've really seen. And you got to have a programmer somewhere in the mix to a software engineer somewhere in the mix to be able to sort of handle that. So that's just my opinion. Every time I get on here, we had a big AI discussion. But yeah, everybody that's out here trying to learn the code, please don't let the AI scare you out of learning the code. It's still room to learn the code and build solutions. Right now you can learn the code with AI. It's faster than we ever could. It's the best time to learn the code, actually, because it's the sweet spot where you can still use AI to quickly learn the code and still sort of get into the industry a lot quicker than people were before. So Yep, ChatGPT isn't gonna write. Yeah, ChatGPT, you want it to, or these AI agents, you want them to, write everything like code. You want it to be deterministic. Like you want it to write things the same way every time, like be predictable. And a lot of times what happens is you don't prompt it right, or somebody prompts it a different way, it does something different, and it creates issues. And so you still have to have somebody in the mix, like somebody that knows something. Helps you understand. Understanding how computers work at a low level makes what you're saying obvious to any real programmer. I probably missed the context of what you're saying. I mean, the thing is, there's going to be a lot of programmers that are not going to like AI coming out because, everybody wants the people coming behind them to go through the same gauntlet that they went through. Even me, I feel that sometimes. But that's just not how it never works like that. Even me, when I came into the industry, I talked to a lot of older programmers. There were programmers that literally, it took 30, 40 minutes for their code to compile. They write some code, and to run it, they would have to go to lunch, eat, come back, and then their code finally would run. And then when they wanted to change something else, they had to wait 30 minutes. Compiling code took a long time. I've talked to coders that didn't even have the internet. They had to read books to learn the syntax of how to code. I taught the coders that had to write in assembly and write in lower level languages, C and C++, languages that are a lot more verbose and harder to code in. People look at them now, they laugh at the languages these older languages. So I didn't have it as hard as them when I came in. I had the internet to help me learn. I had, web development was big. It was we didn't have to ship code on CDs, and then, in order to get an update to our users, we gotta literally print a new CD and send out a new now everything's on the internet. So when the internet was coming out, people were scared that they were gonna lose their jobs. And so, I know AI is different, it's new, it's smarter than anything we've ever seen before, but there's always abstractions happening. So I can't gatekeep and say, oh, you guys don't know the deep details of everything. I don't know the deep details of everything. I didn't have to write. I wrote assembly in one class in college. I don't have to write assembly in my whole career. I've been working for 12, 13 years now. I haven't had to write assembly in my job. We write JavaScript, C#, Java. We write in high level languages. So there's already abstraction there. So we can't get in this boat of trying to like down people for not, knowing every deep level of everything, like of how everything works. Should you, to some degree? Yes. Like you should know as much as you can, but software development that's what it's always been about, is abstracting things. So, whatever you're working on now is an abstraction of something else. A computer doesn't care about JavaScript. Like it doesn't care. JavaScript is for us. It's a readable language for us to maintain code, but the computer doesn't care. The computer just cares about zeros and ones, like operations. It don't care about a language. We wrote these coding languages as abstractions for us to be able to manage code and share code and work with code within a team. We wrote all these fancy words, if this then that, while this do this, and all that stuff. Like the computer don't care about those words. So we are already working within the abstraction. So we can't, we got to kind of put a cap on how far we go with saying how deep everybody needs to learn. So anyway, I get it, man. I'm on the fence of I don't think we should be completely lending everything to AI either. Like you need to be in the middle of it, and you need to be reviewing the code that it writes at all points. In my opinion, as a programmer or as a software developer, you need to be reviewing what the AI is doing. Even if you spin off 3 or 4 AI agents, you need to be in the middle of it and understand what it's doing. Because if it gets to a point where it's written something that you don't understand, then you don't know when it's going in a wrong direction. And it will compound issues, security issues, hidden bugs, performance issues. It builds up things that you don't know, and then you're stuck in a place that it can't get out of, and you either have to rebuild it, or you don't even know what to do in some cases. So that's what I've seen. But anyway, that's my opinion. Like I'm on the fence. I'm embracing AI, but I'm also I'm not on the boat of it's just gonna take over everything, and we're not gonna have nothing to do. I just think the way we're gonna work is just gonna be a lot different than it was before. But yeah. But yeah, I think you should know how to code. You should know how to build software. I think learning how to code is still an important skill. Don't let the AI scare you from learning how to code. I just don't let it help you learn how to code. For sure, to me, good idea. So, when you say projects, you can still learn equally as much, but make something more significant. Yeah, so that's what I always preach is you can do some side projects, while you're learning tutorial projects. But I always say build something real. So find a problem, maybe freelance, maybe ask your friends and family, maybe call businesses and build a real solution or fix some problem for yourself and build something real. Productize it. That's software development, is getting something from the start to end. So what you'll see on the internet right now is a lot of people vibe coding. They're building with AI, but not everybody is productizing. That's a whole different ball game. And productizing something means you got a payment platform set up. You don't have any payment bugs. That's the first thing people. If your app got bugs in it around payment, and you taking people money and not giving them what they paying for, that's your first issue. You got security issues where people can go in there and steal your money out of there. You know what I mean? So a lot of people are vibe coding these apps. They're not seeing it through. Do you have a feedback loop inside your app? Do you have your app, you say you're doing a mobile app. Do you have it where you can get reviews? Is the UI working properly? Is it accessible? Can somebody, blind or deaf use your app? Can somebody that has, is just visually impaired, can they use your app? People can sue your app over it not being WCAG compliant, accessibility standard compliant. So there's just so much more to this stuff than just vibe coding an app. To get an app productized and make money from it, there's a lot of stuff that goes into it. App, service, whatever the case is. And so, that's my spill on the whole AI thing. I mean, it come up every time just because, hey, it is what it is. This is the world we living in now. So you kind of just got to deal with it. But yeah, I think, the T app. Yeah. So what about the T app? The T app, did they get vibe coded or something? A major vibe code related security breach happened today. Oh, the T app was vibe coded? Oh, they left the database fully public. Oh man, that's crazy. Yeah, so I mean, I guess that's my point. I didn't even know that had happened. That's what that T app. That's what happened. Oh, that's crazy. Yeah. Yeah, somebody said AI is not gonna take everything over. It's gonna touch every. Yeah, for sure, man. It's gonna be. You're gonna have to embrace it. But yeah, I mean, cause now when you start talking about robots, like Elon just opened up this restaurant. Since the last time I got on here, he opened up some kind of restaurant that, the robots serve the drinks and all that stuff, and it's a Tesla stop. So you go and charge your car. You go inside a restaurant. I think they got humans in there too, but they got like robots serving popcorn and giving drinks. And so like people are like, well, I'm gonna go to another industry that's AI proof. And it's like, is anything really AI proof if you got a robot that's as smart as a human, and it can walk around and pick up things and do things and fix things and detect things? And is anything really safe from AI? Like, I don't think there's anything like eternally safe from AI. There may be things that are more safe than other things, but it is what it is. Yeah, somebody said vibe coding, I think, is the only way you end up with a database with no awe. Yeah, you might be right about that. KXD, you might be right about that, man. Like, I don't know how they got there. Yeah, that's crazy. I don't know how you get an app to that level of the users and just like have the database wide open. Like, that's crazy. Like, they probably, it's just, that's where we're at now, though. A lot of people are like kind of like getting the trend of this vibe coding thing and building stuff really for like few months, like 3 months. And because they weren't software developers or didn't learn the principles and practices of a software developer, they're just not going to know that they even need to do that. They don't know that they need to secure a database. They don't know that they don't know that software development is more than just building a brand new app with an AI tool. And if you don't tell the AI, they say like, oh, AI is so smart, man. Every time I get in these arguments with people, man, AI it can do everything that you're saying. It's like, it does what you tell it to do as well. And it's not going to do everything that you're not telling it to do. You got to know what to tell it to do. So if you don't know what to tell it to do, and you don't ask it to tell you what to tell it to do, then you know what I mean? Like, now if you plan it out and you tell it, hey, I want to make sure this app is covering all these principles, security, blank, 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 this, that, but you got to know what to tell it to do, either from the start or while you're doing it. And if you don't know, you just don't know. And so, I mean, that's why I just still don't see that there's not a way that software developers aren't in the mix. Now, yes, will it be less software developers? Probably so. It'll probably be, instead of having 10, 20 software developers on the team, you may only have like 5 or 10. It may get more competitive until we kind of really figure out what this AI thing is going to do. And you may have a lot less juniors, because juniors would used to be the ones that would kind of do some of I wouldn't call it grunt work, but like the more simple, straightforward work to like get their feet wet. When you're new to a team, when you're new to development, your first job, they're not gonna give you the most complicated stuff. Like as with any job, you're gonna get sort of the low hanging fruit, the simple task. A lot of these tasks AI can do now, and the straightforward tasks: fix this name of this button, or update this name of this function, or I don't know, just like really write some unit tests for this couple things over here. Like AI can do that stuff like that really well, where it's like a closed, confined environment that doesn't have much context to see, and where it doesn't have much negative chance for technical debt to be introduced. That's what AI is really good at right now, or security issues, or whatever the case is, where all those things have been handled and confined, and it has kind of like a control playground to code in, is where AI is kind of standing out. And that's usually where you actually want to put your junior devs at, because you don't want your junior dev deleting the database or open up an authentication hole in your database or whatever. So you're usually going to put them on something more simple, like, I don't know, like write this code of like using the database to show some records, but it's read only, So, which AI can do stuff like that pretty simple now. So we're in a crazy time, man, but I got faith that I got faith that the people that up their skills are the ones that are going to win in all cases. In all the history of the world, as new things came along, the internet, and all this stuff, social media, all this stuff that came along, the people that continue to grow their skills and embrace the future seem to be the ones that always win. So that's what I'm doing. I'm still on here doing coding challenges. I'm still using AI. I'm still learning how to code and getting better at coding. So I'm just constantly building my skills. So no matter what happens, I got something. So I encourage people to just keep doing that instead of just kind of sitting on your hands and just being like, well, AI is going to take over everything, so I'm not going to learn anything. And it's like, do you think, which position would you rather be in? Like, I think I'd rather be in the position of like, I'm a skillful, I'm very skillful with AI, at the very least. So, T-App seems legally questionable even without the coding issues. Dude, lives can be impacted on gossip. Yeah, I haven't even downloaded that thing or really looked into it much, that T-App. I mean, it just seems kind of strange to me that you just get on there, maybe it should be verified or something. I don't know. Like, I don't know if there's any way to verify this stuff, but yeah, you can just get on there and just say anything about anybody. That seems kind of strange, but I guess it's good to know something about somebody you're talking to. Is that what the deal with the app is? Like, you can look somebody up and see if something weird happened between somebody in a past relationship. I guess that's good, but I don't know. Like, then people can just lie and just make up stuff too. So, I don't know. Doesn't seem. Yeah, and it seems like a simple. It's not any new technology. It's just a simple. Seems like it's just a simple app that just allows you to just share stuff. It's not technically groundbreaking, but it's just they just found a good niche and somehow found some virality or popularity or good advertising or something to get to this point. Because it seems like you could do the same thing in a Facebook group. Like, there's Facebook groups out there where people trash on men and women and stuff. There's already Facebook groups that do that. So just seems like this app is just a more better advertised area to do it, I'm guessing. So yeah. I don't compare it to internet technology compounding on top of previous. I don't compare it to internet digital technologies compounding on top of previous achievements. Yeah, I'll say, I don't know if that's exactly what you're saying, but I will say AI is definitely different than anything we've ever seen. But the internet like was the same type of fear, like people had the same type of fear about different. It killed a lot of industries. It killed a lot of jobs, just the internet when it came about. So I know this is different. I know AI can think and it can, exponentially get better and stuff like that. But, that's just how technology advances. That's just how it moves. So we gotta just see how it go. What other choice do we got at this point? They're not gonna stop working on it. So, everybody's like thinking they're gonna regulate AI. I don't actually believe they're gonna regulate AI. They may regulate it in the sense of what it may be like legal type stuff. Like, they may regulate it from like being able to do anything illegal, or they may regulate who it can talk about. Like, some celebrity might tell the AI companies like, hey, you can't mention my name or something like that. They may do stuff like that, but as far as regulating its growth and stuff like that, I don't think there are, because I mean, you'd have to have global agreements on that, and I don't think we'll ever get to that. We can't agree on anything else globally, for real. So why would we agree to stop progressing AI in any sort of way? Like, why would we put any restraints on it in order to regulate it properly? I don't think that's going to happen. If like these other countries aren't going to stop working on AI, the US isn't just going to say, hey, we're going to slow down and make sure we have these guardrails in place, and then we're going to get so far behind these other countries, like, you know, because the thought is whoever develops like the best AI gets the furthest along with AI is going to be like the most, you know, be the superpower or whatever, like be the future. So I think it's a race. It's an AI race right now, and when it's a race, ain't nobody gonna stop for nothing. So I don't really see regulations happening, but it's just my opinion. So, what IDE is that? This is a LeetCode. I know I'm just on here talking now. I'm just on here answering questions. Earlier, I actually solved this LeetCode problem. Generate parentheses for anybody that jumped in new. But yeah, I solved it probably like 30 minutes ago now, 40 minutes ago maybe. But yeah. Oh yeah. CJP said it's token predicting, not thinking. Yeah, that's one thing I read too. Is the AI is like now it's not even where it could be. Like it's still not able to think. It's just predicting the most probable next token, and that's really all it's doing right now. It's just machine learning, just based off of large, like LLMs, large language models, just like a lot of data being processed over the past. It's kind of looking back in order to sort of predict an answer for you of all these large data sets that it's, you know, processed or whatever. And it's not really actually like thinking. So, I mean, but I don't know. I mean, if it gets to the point where it's thinking, then it's. I mean, maybe this is I don't know. I don't know what the trajectory is for getting to the point that it's thinking. Because, I mean, it's artificial intelligence. So, will it ever really be thinking? You know, I guess it's just how you define these things. Like, I don't think it'll ever be really thinking. But, you know, unless you're just, like, emulating a human brain, which I don't think this is what even the goal of it was trying to do. It's just computers. So yeah, I don't know. It's definitely start to get into the meta thinking of it. It starts to get a little crazy. So anyway, yeah, we've known for years this path won't lead to AGI. Okay, yeah, I get what you mean. Yeah. Yeah, who says we needed to think? Yeah, that's what I'm saying. I don't know. like is it, you know, will it ever really truly, by the definition of thinking, can you say that a non-biological thing without a brain can even think? Like, you know, it's just artificially thinking. And who's to say that what it's doing now isn't considered artificial thinking? Because it's artificial. It's never ever going to be real, you know. And so I don't know, what really is real thinking, you know, like it's electrical currents in our brain firing and snapping, like, you know, is that what we're going to define it as? So then a computer really can never do it, or a server can never do it, or are we defining it as like a server that can, you know, I mean, I don't know, because we're thinking. The way we think and talk and stuff is based off memory and just, you know, from childhood learning how to talk. And, you know, so I mean, like, it's like almost the same thing as like a large language model in a sense. Like all the history of our lives make us up. The things we've learned, the things we've seen, the things we experienced sort of influence how we talk. And, you know, I'm country. I talk real kind of country. I'm from Georgia, you know, so I mean that influenced me of who I am today and what I'm doing now, and how I answer questions, and all the history and things that I've done over the, you know, last decade of programming. So I mean, I don't know. It's a good conversation though, to kind of think about like what this thing really is and where it's going. But anyway, I think I'm gonna call it there. It's like 2 a.m. here, so I appreciate the discussion. I appreciate people jumping in. Somebody said, "Can we see the WoW code?" What's the WoW code? The WoW code? I don't know. I mean, it's the code. Maybe I'm like covering it up. There's no while loop in there. But yeah, anyway, yeah, I appreciate y'all. Like, appreciate everybody that's been commenting. Like, it's been some great comments, great discussion, especially on TikTok. I'm on all platforms, so follow me. Like, I stream on all the platforms at the same time: Instagram, TikTok, Facebook, YouTube, Twitch. Yeah, I think that's all of them. And Twitter, X or whatever. And so yeah, follow me, follow each other, connect with each other. I'll be back on here next week for sure. I post content on all my channels and all my places and stuff like that. So please check me out and DM me if you got questions. Like if you want to keep talking about stuff, if I missed your question or I couldn't answer it, just DM me and we'll talk. But yeah, like I hope y'all do reach out, and I hope y'all come back next time I stream. And I just appreciate people watching the stream and dealing with me when I'm just struggling on certain parts of it, and taking a long time and trying to over explain things. I appreciate y'all. I just love doing this stuff. I love helping people, and I love the comments I get that help me out and help me understand things. And I just noticed that there's so many smart people that's on all these platforms that really know what they're doing out here, and so I can see it through the comments. And so it's like really cool to see and kind of spread, kind of see the community that's online. I think a lot of people don't think there's any value on these platforms for like technical people. I mean, they see the people posting technical content, but like people really are the real smart people really on here commenting and talking. And I know for sure that's true from what I see. So anyway, I appreciate y'all, and yeah, hope I see y'all in the next live or my content somewhere, or in your content somewhere. So appreciate